The work of the Siver Data measuring system is based on the principle of binocular vision. According to this principle, if in the field of two video cameras there appears a sharply defined object, for example a bright little star, it is possible to calculate the multidimensional position of the star by taking pictures from both cameras. In our system, instead of using a single star, we use a specially made contrast object, a so-called pointer, with LED lights located on the lateral side of it. To determine the exact 3D position of each LED light, consequently the pointer's position itself, and, the most important thing for us, the exact position of the pointer's top, we need to capture the pointer on two cameras. Therefore, after touching the pointer's top at any point, and taking a picture on two cameras, the computer will be able to calculate and save the coordinates of this point. In the same way, it is possible to touch the next point and capture it, then the next one, and so on. Step by step, by measuring and saving the coordinates of all the required points in the computer's memory, the measuring process is completed. So, the Siver Data measuring system consists of a console with computer, monitor, and printer, a measuring pointer with a set of removable adapters, and the main block, the lightweight and firm metal measuring beam with built-in two video cameras. To understand the principle of how to position the measuring beam in relation to a vehicle's body, let's first have a look at the dimensions of the working area. For example, the dimensions of the area where the LED lights can be correctly captured and measured. As we can see, the working area is enough in width and in height. But the length at first sight seems not quite enough for the measurement of a modern vehicle's body. But the great possibility of combining two measurement cards, provided in the Siver Data system, not only removes the restriction, but also allows to include points located in different sections of the vehicle's body. For example, points located on the rear bumper and in the engine section, in the general list. To properly understand these and the features of the measurement system work, let's produce together, step by step, a measurement of an entire vehicle. First of all, we need to check the vehicle's model in the database. After finding and choosing a model, inspect the available information and decide which points must be measured. The database includes information about coordinates and photos with schematic symbols that allow comparing points from the database with the measured points. So, we decided to measure points located on the underbody, on the front and the back, and in the engine section. For more clarity, let's imagine schematically this vehicle's body. Total length is 4.5 meters. That's why we have to measure the underbody points from two positions of the measuring beam. At the beginning, let's position the measuring beam under the front part of the vehicle, so that the entire vehicle, except the front section, will be in the working area. The front section will be measured from the beam's next position. So, while the measuring beam is inspecting the underbody, we can touch the reference points with the probe and measure the point's coordinates. In our case, we can position the measuring beam directly onto the surface of the platform. In case the vehicle is raised on the regular lift, simply position the measuring beam on the specially designed support. And now, let's look at the real state of things. First of all, let's position the measuring beam on the platform under the vehicle's front section. We are beginning to prepare the measurements of the underbody points. In the central section, it is suitable to use the regular probe. But to measure this and this point, it is necessary to use the movable probes. For measuring points on the vertical surface, we will use the lateral probe. And in this one, we need to use the extra long probe. Otherwise, some of the LED lights will be out of the camera's field of view. Having finished the measurements of the underbody points, we have to complete the series with the measurements of the points located on the rear, using the lateral probe again. So, we have already measured all reference points in the central and the back sections of the vehicle's body. Now, we need to proceed to the measurement of the front section. For this, we position the measuring beam on the platform under the back section of the vehicle, so that the central section is in the working area. In order to make the computer combine the points measured from different beam positions, we need to measure the several common points in the central section again. After measuring the common points, we can proceed to measuring points on the longerons and on the front. As soon as the system combines the results of the two series of measurements, the monitor displays the plane of the whole vehicle's lower section. Now we have to add to the plane the coordinates of the reference points in the engine section, the attachment points of dampers. For measuring these points, we have to attach the beam on the support and position it approximately 2 meters from the front part of the engine section, so that the underbody and the engine section are in the working area. To combine the results of the different series of measurements correctly, let's measure several points in the lower section and the attachment points of the dampers. After we have completed the measurement process, we can move to the process of analyzing the measurement results. If the model of the vehicle exists in the database, the program will automatically match the measured points with the specifications. The result displays in the graphic and chart views. On the display appear displacement vectors of the measured points. Points with a deviation from the specifications of less than 5 mm appear green. Misalignment points with a difference of 5 mm and more from the specifications appear red. The chart includes more detailed information, the misalignment of each point relative to the specifications, and separately the misalignment of the coordinate relative to each axis. If the database doesn't contain this model, it is possible to use the principle of symmetry. A program, according to the measured points, will define the symmetry axis and calculate the misalignment of each measured point relative to this diagram. Also, clicking between any two points, the distance will appear on the graphic. Thus, as a result of using the Siver Data measuring system, we have got a measuring report, which contains data about the real condition of the vehicle's body. It can be useful for making a decision about repairs, as well as referencing during the repair process.